Aerobic training improves endurance through three major adaptations: cardiovascular, muscular, and pulmonary. Together, these three guys allow your body to deliver more oxygen to working muscles, extract more oxygen from the blood, and use that oxygen more efficiently to produce energy. My main focus for part 1 and part 2 is the cardiorespiratory endurance, which is how well your heart, lungs, and vascular system work together to deliver oxygen to the working muscles, allowing you to exercise. Let's say an athlete completes an endurance training block and their performance improves. How do we know that improvement came from cardiorespiratory adaptation and not something else, like better running economy? One of the best measurements we can use is VO₂max. VO₂max is the highest rate of oxygen consumption that can be achieved during maximal exercise, reflecting the body's ability to deliver and use oxygen during maximal exercise. To understand VO₂max, we can use the Fick equation. According to the Fick equation, VO₂max is determined by cardiac output and the muscle's ability to extract oxygen from the blood. Cardiac output is the amount of blood the heart pumps per minute and is calculated as stroke volume times heart rate. The other component is the arteriovenous oxygen difference, which reflects how much oxygen the working muscles can remove from the blood and use it for energy. Therefore, improvements in stroke volume and oxygen extraction leads to higher VO2 and endurance capacity. During a maximal effort exercise test, VO2 increases as exercise intensity increases. However, at some point, VO2 will plateau or even decrease slightly, even if workload increases. When this occurs, it indicates that VO₂max has been reached and the body has reached a point of maximal capacity to consume oxygen. I think we made it clear that endurance training improves VO₂max, making the body more efficient at delivering and using oxygen. But what does it actually mean for performance? Well, as VO₂max increases, athletes can exercise at higher intensity, sustain those intensity for longer periods, and achieve greater peak exercise speed. In other words, they can go harder for longer and faster. Submaximal endurance is the ability to sustain exercise at a moderate intensity for long periods of time and improves with endurance, but it is harder to measure than maximal effort VO₂max. So we can't really rely on VO₂max alone, so we have to measure heart rate response, sustained power output, and sustained running speed. The heart rate response refers to how long your heart is at given submaximal workload, which reflects improved cardiovascular efficiency after training. Sustained power output is the amount of force or work you can maintain on a bike or similar equipment, but usually it's mostly used on a bike over a set period of time, showing your ability to hold a high effort. Sustained running speed is the fastest pace you can keep up for a prolonged duration, which reflects overall endurance performance. So in summary, endurance training leads to important adaptation across a lot of systems. In this video, we focus on the cardiorespiratory system. These changes improve VO₂max by enhancing the heart's ability to deliver oxygen and the muscle's ability to extract and use it. As a result, athletes can perform at higher intensity, sustain exercise for a prolonged period of time, and achieve greater peak speeds. While VO2 reflects maximal capacity, real-world performance is also captured through measures like heart rate response, sustained power output, and sustained running speed. Together, these variables show how the body becomes more efficient and capable through endurance training.